that he was servicing.
Yeah, doesn't surprise me. All
Oh,
right, we're at the top of the hour here, guys. So I'm just getting the recording going. All right, we're live, recorded to the cloud. Here we are. I made it back in time for today. Sorry about no AI or no Vibe Space vodcast this week, but we have the AI Hackerspace, so that's good news. And it's been an incredible week. I for those that don't follow the godfather of the internet, or I guess the inventor of the internet, reached out of all places on Facebook, which is kind of funny because I don't really use Facebook that much. So when you get in the morning, you're looking through your phone and all of those sort of notifications. I'm like, Vince. I'm like, what? This just can't be right. It must be like a hacker or something. Someone that's trying to like pull pretend something. So I took a few hours and then I went back and took a look and then I'm like, oh, there's a blue checkbox. So it looks like it checks out. So I sent a message and yeah, it turns out it was him. And apparently caught the Rue Vector DNA stuff caught his attention. Apparently he's been really into the same sort of stuff that we're doing. So there we are. I sent him all my Notebook LM presentations and said go point Gemini at the repo and see what rabbit hole you can fix or
right.
find. Yeah, yeah. Rob, how's it going?
Great, great. Welcome home. It was
Yeah.
yet another red eye for you. Eh?
Yeah, a little red eye. I'm a little well, a little tired, but we should be good. Sounds like we got lots lined up today.
Yeah, absolutely. And I mean, we're all sort of waiting with bated breath to hear about the Cognitum launch in Portland. But as far as today, we've got our OGs. Chris Royce is here. He's got some stuff to show. And Mandeep had an amazing inaugural event in Assam, India. So he's going to share some stuff with that. Brad's might have some time to go through some of his AISP, which we've all been exploring. So yeah, tons on the go. And then as far as chapters, quick shout out, Budapest, Hungary's got their first event next week. Akema, who's on the call
That's
today,
right.
had an amazing event uh, just in Halifax last week. Sorry, did somebody say something?
Yeah, I just said that's right, as you say, Rob. Exactly.
Yep, the Budapest is Hungarian chapter. It's February 25th, next Wednesday. And then that's the same day actually as the New Zealand Hackerspace. And then Halifax, next one up is March 10th. 10th. I know Craftsman is planning his first chapter launch, I think around the same time, coming up late next week or early March as well. So tons of stuff going on. Nick was just on with the guys out of Milan, Italy. Is that right, Nick?
Yeah, and Nuremberg is coming up as well. So that'll be the first live event, in-person event in Germany. So we're pretty
Germany.
hyped about that. And I think it's started to spark some interest from some of the other cities. They saw Nuremberg get posted up there, and then all of a sudden it's like, okay, well maybe we're gonna get involved in Munich and Berlin and stuff like that. And the good news about Milan is that there is a 42 campus, right? So we have
Beautiful.
that backing us up. The gentleman that's interested in participating as the local ambassador also has access to a museum. So they hold free events for nonprofits. So that that looks like it's going to wrap up quite nicely. Is a lot of experience in the community, and there's a lot of other ones popping up. It seems like the European crew is anchoring the live event drive in the early 2026 here.
Nice. Lots going on. And Rob, you've been busy organizing some new events and some activities. And was it Hungary? Is that what?
That's right. So we've been invited to go to the Cross Conference in Budapest again, June, the beginning of June. I think it's the
Cross or
it's our
craft?
two fifth
What's it called?
craft conference. That's right. And that's yeah. So that's we should have
It's in the
everything
chat. Just
solidified.
check.
Perfect. Thank you. Over the next week or so, and a whole bunch of us are going to be there, right?
Yeah, we're gonna meet there first time in live then,
And
it's
Yeah.
like
Yeah,
yeah.
yeah. I
Brenda
look
has
forward
given
to it.
us the 90% all clear. So we're just waiting. We want to respect the process. Ruve and Brenda and Finnegan all have to confer, but so far it's looking really promising. We're hoping to get Ruve out there and Finnegan as well if that all works for the Cohen family.
Yeah, maybe we'll do a hackathon or something. You were suggesting an all-day workshop, but I'm thinking maybe we do something a little more creative. Like we can combine the concepts of workshop with maybe a hackathon or something where we build together. I've been doing quite a bit of those. That's actually lately been my sort of go-to little business move, I guess. That's what I was doing mostly this week in Portland, other than my crew flew in to meet and do our kickoff of the semiconductor stuff that we're doing. But yeah, it was a healthcare hackathon essentially, and very one of those giant companies that has tens of thousands of people kind of sort of thing. But we basically took their data and took the approach of Claude Flow and well, I guess what I'm calling Roof Flow now. And I got to finish off that rebrand, but and built interesting things. And what's the takeaway from a lot of the work that I'm seeing, especially in healthcare, which you can tell I've been a little bit obsessed with lately because I'm doing a lot of work in the healthcare space at the moment, is the min cut algorithm that I keep talking about. And it's this the biggest breakthrough that I've had over the last year probably is this algorithm. It just finds the most astounding things by looking at like the background, like filtering out the background noise, looking at the difference between what it is and what it should be, and then finding these bizarre patterns in just about everything it looks at. I'm really surprised like no one else seems to be talking about this algorithm. It's absolutely astounding, and it's ridiculously fast because it simulates the anti-pattern in real time, so you can basically do these really intricate, complex, interconnected relationships of a graph that change and adapt without having to recalculate the entire thing, which works really well for healthcare. So anyway, a lot of that sort of thing.
Yeah,
Yeah.
and one more thing is that next the Android conference from Berlin reached out and they want a cooperation with Agentix Foundation
Oh,
in
nice.
October in Berlin.
And
Yeah,
we're gonna have a call. There's a call right after this meeting? Is that right, Benza?
No, it's next week, I guess.
Next week. Okay, very good. Yeah, next Thursday. Yeah, that's really interesting.
This is the link in the chat for the Berlin one, the German one. It's a global Droid, Flutter, React, XR games, Swift, iOS, and they want to embrace the AI Agentix methods because they are behind.
And you said Android, like the operating system?
Yeah, iOS, Android, so devices. Yeah.
Well, there's certainly a lot of opportunity to use Android and related technologies for Agentix, which actually kind of segues really well into what I built after last week's AI Hackerspace, which I want to show you guys. And and Peter mentioned this earlier. It's a package. It's a file format. How boring is that? But it isn't. It's everything in one place. I'm gonna show you what I built. So I'm gonna show you both this and an app I built, which is also astounding using it. So basically what this is a format. So if you're familiar with things like Docker essentially uses a kind of shared environment. So it's not really quarantined. This is completely quarantined. So it's a single file that includes the latent vector graph attention and as well as the ability to include a custom kernel or Linux kernel in the single file that's then rendered or I guess compiled to a RVF format. So what that means is you've got one format that can run from everywhere from the bare metal on up, and with one package. Everything is self-contained into a single binary. So what that does is essentially allows you to combine an embedding model, a language model, a self-learning, a self-expanding system. So again, you can ship a model that includes a piece like a DNA analysis. Not only does it include the pre-computed DNA analysis, it can also unlocked just for the person's DNA because it's got a runtime that can run and then do the correlation, which I figured out how to do super fast. So I could do it for, I wouldn't suggest doing a DNA as a form of authentication. You lose that and you're, there's no turning back when your DNA gets out there. But hypothetically, it's kind of a cool futuristic sort of oh, getting some feedback. I'm muting everybody. There you go. All right. I don't know what that was, but anyway, so basically, it gives you a kind of everything pattern under the sun. So it gives you security. It gives you the ability to lock to kernels. I've got lineage. So as you create new files, it uses a pseudo sort of DNA lineage, kind of like RNA, where it tells you where it came from and sort of the lineage of the file itself. I've built in the trusted execution environment, so it's secured based on both the Intel AMD sort of TEE for those in the security space. Means it's completely sort of locked down. It's basically it's got everything but the kitchen sink. Lots and lots of stuff in it. So, but the real question is, what the heck can you build with a single file that contains everything, including a language model and data and the AI? Well, the other day I built a system to find planets using real information from the JWT observatory, which is I think 1,000,000 miles out in space and a bunch of other places. So there's different settings and things. So what you're seeing here is a rendering of some of that. But the more important part is, how do I know it's real, and how I know that it's not BSing me into thinking that it's something that is a convincing forgery. So I needed to do a blind test. So what this does is, first of all, the blind test basically says the JWT and other researchers have found planets, several of them. Can I find the same planets without telling the system what those planets are? Right. So it's a blind test. So if I can find the same planets without the system knowing what those planets are, then it's a pretty good indication that the system will work in a similar fidelity. So what this does is basically, first of all, does that same analysis, and then I've got basically 100% fidelity. It's saying 94, but it's actually 10 out of 10. So that's 100% to me. So what this does is it runs across 5 million potential planets, and I pre-computed it. That's why it's happening so quickly at this point. But it runs across 5 million potential planets, looking for different, looking for that wobble in the light, but as the planet goes behind the star. All right, so we got that working. So now I can go in here and I can then visualize it and see the information relating to the planets that I've discovered. So
transient dimming, Roof, and I'm sure we have somebody from NASA on today. But keep going, amazing.
Yeah. So I can see the different planets I'm finding. I can see the signatures. I can see the detection. This is kind of cool, but at this point we're kind of used to building. This is one file. It expands. It's secure. It's got both the internal workings of my root vector learning and the vector space, the latent space, the attention, the min cut, and all the other crazy things I built over the last several months in a single file that's running and can run without any internet connection. So I don't need a connection to Claude or anything. It's 100% self-contained. Now I can go in here and I can look for signs of life. So, all right. So according to this, and again, I probably need someone from NASA or something to validate this. But according to this, it found several potential targets with biosignatures that indicate potential habitability, not just habitability, but actual life signatures. And this is also using that idea of mincut to look at the inverse of any problem to try to find those. I can visualize it, and it's saying I'm using the James Webb telescope data, and it found, and according to this, no one else has discovered it, and I need someone other than me to peer review it, just to be honest, but pretty interesting. Now, as the thing happens, because I've got a deterministic system, every step along the way can be has an attestation. So that allows me to cryptographically verify exactly how and where and why the process that went through it to find it was actually executed. Now, taking it a step further, I include a solver. The solver acts as a kind of pseudo form of, I guess you'd say AGI. It's self-aware. It's capable of adapting, understanding, taking steps back. So if it made the wrong choice, it can go and then make a new choice. So it reasons on its own reasoning. Keep in mind, everything you're seeing on this screen currently is happening, without an internet connection. I can give it an internet connection because it's a kernel that I can design myself. So if I want a network connection or a POSIX mount or whatever it is that I want to do, but right currently, just to show off, I'm running this without, this is completely self-contained. So this system could run literally in a satellite. It could run, in a sensor. It could run anywhere it needs to be. So in this case, you can see the pipeline. And this is actually a real-time pipeline using the WASM. So you can see then this is searching, I think, 5 million different potential planets, and it does it in under 10 milliseconds, and it renders an animation for what the potential what it potentially looks like. And I could probably render this even more if I wanted to. I did this quick. This entire thing was built in about an hour. So you can see it's finding new planets. You can see here it's discovered potential candidate, the most Earth-like candidate in the Kepler catalog currently that I was able to find. So it's finding novel new things, and this is going to be, I published this on my RuVector. It's in the RVF folder. So if you want to try it, you can also compile this to an exe if you want to run it on Windows, or a DMG if you want to run it on Mac. It's a single file, no installation. It just kind of works. So then the guys I was with this week, they're like, okay, let's see if you can take it. Have you heard about this new Dyson sphere research that just came out? And they think they found some potential candidates for Dyson spheres. So first thing I need to do is see, okay, can I find the same Dyson spheres that these guys that at the university, I think they just announced it like this week, that they found 7 potential candidates for Dyson spheres where there's kind of less biomass than should exist, which indicates there's potential, or there's no biomass at all, but there's like a sort of gravity void that they found. So it's like, well, what's going on there? So all right, let's see what I can do there. So I did a blind test, and of course the system, and this is data that just came out like this week kind of thing. So it's not going to be hopefully too much influenced by any kind of training data. But again, I'm not using a language model, so I don't think that would have any influence. This is 100% sort of mathematical based. Again, running in a single file. So now I can go. Now I can do my own search. Now this is again searching. I know the font's a little small. I'm packing a lot in here, but it's searching the entire JWT data set, which is massive, in seconds, like microseconds, I think. And of course, it's found some different options for me, and it's telling me how I found it. And this is the Tabby star, which this is someone else's finding, but these are my findings down here. And yeah, I'm basically looking through 5 million different planets in some ridiculously low amount of time here. And again, it's completely self-contained. Here's a documentation if you guys are interested in trying this or modifying this. This same thing I'm showing you could be applied to any really complex data analysis. Like I did 5 million planets because I just was trying to show off to an audience kind of thing. But this could be just as easily DNA. It could be financial data. It could be any sort of data lake, that you want. And it's using all the different sort of components. The blind test is a really useful approach for doing this kind of data analysis, because a lot of people are like, sure, man, you found 22 planets in 100 milliseconds, whatever, buddy. So I needed to prove it by doing blind tests. And after I did the blind test, it kind of works as a nice kind of confidence builder for whatever you're building. It's with great claims requires great proof or something. So that's providing that. Here's some more logging. I've got my memory system. I've got my bounds. So this is defining the sort of bounds of how it's learning and where the coherence of the system is. So just again, what's happening is I'm not asking the system what the answer is. It's looking at the coherence or the min cut of the anti-pattern of the environment, and then trying to defer or infer, in essence, not what might be, and then deterministically describe that through a series of actions, which are then using a witness structure to sort of cryptographically verify, all in some ridiculously low amount of time. So the coherence here is hard to describe, but the most important part of the discovery mechanism itself. And as far as I can tell, because I don't think anyone else has created a dynamic min-cut algorithm at this point, I'm the first to ever think to even point a dynamic min-cut at planetary information. So I might send this over to the SETI guys and see what they have to say. But I'm finding all kinds of crazy stuff, and it's kind of fun to play with if you're interested in just the absolute most absurd kind of thing you can possibly find here. Yeah, and the other thing I can do here is I can just run a chat system. So again, I can embed a language model. Here I'm running. I think I broke it right before. Oh, here we go. I can run either the Hugging Face system, which gives me all kinds of like MCPs. You can see here I got my Ruve Ultra Small and my Ruve LLM and my Ruve Sim optimized models contained in the single RVF form. So not only can I pack all the other stuff in it, I can run a language model on a CPU, maybe a GPU, but this one, it in its own little environment. The great thing about Hugging Face is I can include additional MCPs and things like that. But if I want to create my own little model, this is just a little chat thing I created just to show. This is also running in the RVF on another port. So this is port 3000. This one here is on port 5173. So the cool thing about this is when I embed a language model, I don't need the language model to be smart for everything. I'm not going to ask it who the King of France was, right? What it does know is specifically the information that I needed to know in the narrow focus of the purpose of the thing in which it resides. So if it needs to be smart about the diagnosis of a cancer patient, not only can it tell you about the diagnostics of the cancer, it can also do all the sort of learning and optimization, the analytics, the sort of self optimization patterns, all independently of the chat system. While you're interacting with the chat system, because it's got tools and MCPs, it can then update the language model, the LLM itself, using the micro lower capabilities, so it gets even smarter about that particular thing that it needs to know about. So in that scenario, I'm using a 65 megabyte, half billion parameter, basically fine-tuned version of Gwen, and it works. It's totally functional. This again, like I did. This is you're seeing it in real time using the model. It's a little wonky because I asked it a question outside of its bounds, but it's giving me a sentence transformer so I can fine tune it a little bit. Yeah, that's what I've been up to. If you're interested, I'm going to shoot you a link in the text area here. And I've got one other thing I'm going to tell you guys about. Again, it's a little self-promotion, but you guys can deal with it. So Cognitive One's coming together. There is an absolute ton of interest in this. So everything I just showed you can run on this chip. So the chip is, here's what we're going to do. I'm going to do a pre-sale. Now, I didn't want to do a pre-sale that involved like giving you a t-shirt or something that wasn't going to work. So here's what we're going to do. I've come up with a very small little appliance that is basically the cheapest, most useful sort of part, not most useful. It's a little sensor basically using the Ruve vector components that I've been showing you, and that'll be the thing I give you. And I think I can probably get a few thousand of these really quickly, like in the next 2 weeks. And there's tons of interest in this thing. So what I'm going to do is this. We're going to get you when you do the pre-sale, which I think we'll do around $100 or something cheap. And so rather than sending a t-shirt, I'm going to send you the sort of Ruve vector seed. The seed will contain all the sort of the Ruve vector stuff and the components built right into this tiny little appliance. But it won't include language model. Like that'll come in the appliance that I'll get you guys. But what it will do is get you basically working on the ability to do real-time sort of sensor-based analysis. So you can point this thing at your computer. You can, it'll have the my desktop app, so it can optimize your laptop. Here's what it kind of looks like. So this will be the mechanism that you use to, discover and learn and use the system a little bit. So it'll be a little desktop app kind of thing. And then in a few weeks after that, I'll get you the appliance. The appliance will be basically the full the full meal deal. It'll allow you to run the local language model, do all the learning, and it'll be, hyper optimized. So it's like 1,000 or some crazy percent faster than running it, in a CPU or a browser. Yeah, so everything's coming together pretty good there. And then, the chip run's taking a little longer. I guess chips take longer than anticipated. And we should have the first ones probably late spring, and for broader distribution, I don't know, probably in the summer. Let's say fall at this point, but it doesn't matter. I'll have the appliance and everything well before that anyway. So that's what we're gonna have. Yeah, everyone's really into this idea of a kind of sparse spiking agentic chip that runs on almost no power and can run for extended periods. That appliance will support probably 150,000 always running agents. So think of, like, if you're doing, I don't know, medical or even like a finance bot that needs to basically sleep until the right moment to do a particular move. Or yeah, it's all open source. It's root vector in the most simple sense. What I've done is I've taken all my root vector stuff and I've slapped it into a WASM and put it on a chip. So hypothetically, if you wanted to run it today, you could just go run my root vector stuff. It's obviously not optimized for the chip, so the chip runs at wire speed, where this would run on a computer essentially. So it's still fast. Don't get me wrong. It's just not as fast. And CPUs use a lot more energy. So my system runs on 2 watts or something like that.
You mentioned RBF having a Linux kernel in it. I thought the Cognito one was a MCU based thing. Does that also have Linux on it?
So this is my runtime. So I'm for that I've created my own kernel. Because I could. But the example I'm showing you, like these apps I'm showing, that I was showing you, is actually this is running a tiny Linux kernel, 5 megabyte size, and then I'm using my favorite Vite.js, and then I have the back end is my root vector, so I'm using the root vector drop-in Postgre, but I'm not using actually Postgre in this sense because I didn't need all the Postgre stuff. So yeah, it's all self-contained. The package is kind of crazy. I won't go in it. We don't have enough time to go into it. Maybe I'll do it next week on the livecast. But yeah, this is all one file and literally run anywhere, no installation, which is the most incredible part of the whole story. I built it for the chip. So this is meant to be my operating system, right? So at this point, root vector is its own operating system. Again, it runs everywhere from the chip all the way on up. It'll run, in any environment, bare metal, Linux, Windows, Mac, whatever. And again, it's almost like, if you want to use an analogy, think of like a zip file, but the zip file never needs to be unzipped, and it auto expands. It's operationally sound and can do everything in a quarantine sort of emulated kind of state, which is, I don't think anyone's done, as far as I can tell. If you find me something similar,
the checkout's not working for it, the pre-sale.
yeah, I haven't launched it.
Ruv, when do you plan on splitting the atom next?
Right on it, Danny. Sorry, go ahead.
I was just curious when he plans on splitting the atom. I figured that comes next, right?
Oh.
Diving into quarks and having this at the quark level or something.
Oh well,
Funny you mentioned that.
Yeah, funny you mentioned that. I've been able to get now a simulated 70. I've gone full Kobe, but I've been able to get a 70 qubit simulation without using a quantum computer. Now it's for exactly that scenario. You can do 35 trillion calculations a second, which allows you to do really detailed modeling on an atomic level. That's how I actually ended up doing the actual modeling for the chip itself. So when I went in there, I needed to figure out exactly, well, how am I going to work on, within the bounds of the sort of atomic scale? And I don't know anything about chips either. So I went ahead and created the entire simulator to do that, right? So when you go in here and you're looking at the structure and you choose a semiconductor, this is what the atomic structure of the chip actually looks like, which is astounding. So this would be, I think it's 1.8 nanometer, but the 1.8 nanometer is just crazy. But here we go. So now I can adjust it. I'm going to turn down the I'll turn down the temperature to absolute zero. We can see the atoms stop moving. And what's interesting about the structure is it's learning, right? So what it's doing is the inverse trajectory, and it's learning the optimal path of the atomic structure. Then it's attempting. So now I've learned the optimal structure for the flow of the atoms within the chip and the interconnected relationship between each of the tiles in the chip. I can then get to a fidelity where I can then optimize the actual silica itself, specifically optimized. In this case, what I want to do is get back to room temperature. And so this is in Kelvin. So you guys got to tell me what Kelvin room temperature is. Probably around 200 and 300 or something. And this is going to show me how it performs at different temperatures. So then I can put a thermal optimizer on the thing, and the thermal optimizer allows me to optimize the sort of temperature settings of the actual system itself. And before the Americans in the room ask, it's Celsius. Nobody uses Fahrenheit, just as an FYI, except for I think some random African country in America. No, it might be Liberia. Never mind. It's not a random African country. Anyway, so this is showing. So now that I've got control of the sort of atomic flow, I can then optimize the specifics of the sort of thermals of the chip itself. And why that's important is I don't need a fan. So when you get the initial sort of appliance, you're going to notice, well, there's no heat sink in it. That's because I'm optimizing the chips themselves in real time and across the sort of pattern of the tiles. And on my laptop, when I show you, my desktop application or whatnot, the same thing is essentially happening. So yeah, and I can look at my neural fabrics. Here's my tension mechanisms. I can go in there because everything's now a single file. I can go into a store, grab the model, the root vector, and I can install it on the environment. And I've got full control over each one of the chips. So I've got 257 cores because everything I do is a prime number. But anyway, I've got full control over that. I can install it, I can deploy it, I can see my apps, I can do all my different components. It's almost unimaginable. So yeah.
So
anyway, that's what I'm working on.
So jesting aside, honest question, and apologies, I've been out of the country traveling for the last month, so I've missed some of this really amazing stuff that you're onboarding. How do we get a sense on how we use this to build WASM-based, knowledge-based private applications that we can use for ourselves or for clients that have all kinds of everybody's terrified of their enterprise data leaking out on AI, and everybody's shutting it down on all of my clients. And we want to be able to show them they can do things safely. This feels like it would be a way to do that. Not looking in any way to change the conversation today, but
no,
is there anything you can point us to that will help me say, great, here's how you go use this and build with it?
Well, that's what I was showing you with the RVF format. So that's 100% self-contained, no network connection required. So let's say you've got some kind of medical device that needs to keep working when the internet goes out or the power goes out. And you don't want to offload that to the cloud. Maybe there's data privacy concerns. Yeah, that provides the ability for a single congruent package. Now I can send you that package, slap a encryption on it of some sort that allows you only you to gain access to it, and then it's deterministic. So the ability for you to then have the same results as I do, because it's not a probabilistic model. It's a series of deterministic systems, allows me to share. And then let's say a multi-tenant system. Let's say I'm building a system that requires a million different tenants, but they all need to be quarantined. That means I can separate each one of those million tenants into these tiny little RVF files there, and then I can share bits and pieces of the learnings of each one of those tenants through the trajectories, meaning I'm stripping away the how it's learned and the personal identifiable information, and then sharing the insights across all million without sharing the details, which is kind of cool. So it's optimized for exactly what you just said.
Interesting.
Is there any easy way to prove that out to a client? Because barring them sitting through the last 8 weeks of these weekly calls, they're not going to have any idea the level of science fiction that you're talking about. And you've even said that tons of learned people are claiming that you're hallucinating just because they don't realize this is possible. Have you thought about the communication part of how to explain what this is and what it enables? Because it all seems like it's magic.
It is
And for
magic.
a lot of lesser minds, they're not going to be able to grasp this.
Yeah, it is a little bit of magic. I'm not gonna lie. Like I can't explain all of it to you, and I don't pretend to be able to explain it all to you. That said, the customers I'm working with are very large. A lot of them are in the medical space. I'm talking, tens of millions of potential patients on my system as we speak. So yeah, there's certainly a level of proof, but once the teams get a feel for how it works and the blind tests and the analysis. And keep in mind, a lot of traditional sort of data analytics is a best guess, trial and error already. So when you're going and doing these kind of, deep learning systems, most people can't explain exactly how those deep learning systems work, even in Python, let alone the things that I'm doing. I,
Yeah.
on the other hand, have a witness system that basically gives you cryptographic proof of every step to get to that sort of answer, right? Where a traditional ML model just kind of, you slap enough data at it, you fine tune it, you play with the parameters enough, and suddenly it matches the criteria for what you're looking at, and you're saying, oh, it works. That's even worse.
Does Claude Flow V3 know how to use it? I guess is the question.
It is Cloudflow V3 is it. Yeah, so
Because you
Cloudflow
always
V.
said the magic was in Root Vector for the crazy, and Claude Flow had a subset or a smaller rev of that.
It is. It is Claude. So Cloudflow is root vector. It's just packaged a little more cleanly in the single sort of npm distribution.
Okay.
Manjui, you got a question?
No, I just wanted to marry this into a discussion we had yesterday with Nick. So Nick, I'm going to bring in your initiative about, I guess, helping organizations adopt some of the new tech, right? So if I try to summarize what you were trying to do is all the repos, I think mainly from Roof, is to make it the whole discoverability process of kind of using agentics better accessible to SMB businesses and corporates actually. So I'm just thinking like here, if a chip is embedding all of the capabilities that we have been discussing, is that something that we should look at to see, well, here is a framework or a mechanism for a CIO persona? I mean, Rube, my point here is that how do we explain this? And I think some of this goes back to what Stuart was saying. How do we position this and explain it in a manner that is really straightforward to the decision makers of many organizations who are stuck for whatever reasons in different areas? So as a CIO, this is what it does. And by the way, this is how we go about it. And Nick, what I'm saying, does it make sense or align to what you have been working on?
Yeah, to some extent, right? Like a lot of the infrastructure that I've been building, I've been using Roof's tools, and now I'm at a stage where I'm actually going back to those repos to say, okay, Claude, what Roof crazy exists that I can bake into this to like enhance its capability, right? But yeah, in terms of the concept, getting helping people or key decision makers decide faster, as opposed to it being like months of this long drawn out discussions and McKinsey and Boston Consulting or whatever getting involved. Like they could run 1,000 of these in a single day, for example, like of what they might pay like $1 million to
Well,
do over 3 months.
there's two there's two things I'm going to note, and this first one might be self-evident, but by the time a CIO reaches out to me, they're kind of already drinking the Kool-Aid. All right. And I that is my advantage. I don't really need to sell. They've already tried it. Some random company has 250 developers on Claude Flow or and this is literally like a almost daily occurrence for me. Or they're using React and they're like, we have absolutely no idea how this thing works or why it works, but it solved all our problems. Can you explain it to me? And I'm like, well, no, actually, I can't. But I can do. I'll help you discover what it is that we need to know to sort of understand your data better. So I have the advantage of being the creator, and then that leading to my opportunities, which doesn't work well for you. In fairness, you're not the creator, so they're not going to come to you. So you're saying, how do we sell it? So what I've discovered, and this also might be a little bit obvious, but the putting something on a box sort of gives it this weird sort of tactile real world it's a thing more than just some random repo of stuff. And I find that when I show up with a box and I'm like, hey, look at this little device that can actually see through walls and things, and I put it on the screen, it makes it more real and it's easier for them to consume. So the actual sort of tangible appliances that I'm creating, I think might make this a little easier to sell, and ultimately that also provides a kind of easy, low friction capital expense where consulting sometimes is a kind of ongoing OpEx. So what I'm doing is I'm shipping them a little tiny little prototype and saying go try this, plug this into your computer and see what it can do, and then with a little dashboard or whatever that makes it easier for them to navigate it, and that makes the sale easier as well. And as you can see, I'm getting Vint Cerf reached out yesterday, so we're doing something right. I don't know.
Awesome.
Just a very quick follow on. Could this also, I mean, you probably have already answered the question, but the whole local AI adoption. So is it a substitute for the traditional way in which I guess local AI is done today? So setup of, so if you have a problem and you use AI for certain discovery work, etc., or long drawn, let's say a corporate discovery of what exists, will the processing be entirely possible through these devices?
Yeah, 100%. It's self-contained. Like I'm saying, it's 100% self-contained. Now, the language model isn't going to. You're not going to use it like you're using Claude. I can use it for coding, and I've optimized it for coding as well. But you're not asking it for like broad sort of figure it all out. Tell me the meaning and the kind of discussions you'd have with ChatGPT. It's optimized for the purpose of the application it sits in adjacent to, right? So it's going to tell you about the industrial control system that it's been monitoring for the last 5 years. It's going to learn how to optimize for the signals coming out of that industrial control system, and it's going to allow for a communication with it. Now, I put a CNN on that. You can chat with it like it's Alexa. Now, it's Alexa, but doesn't sit or connect to a network, right? It's Alexa minus the cloud. So that means you've got a button or a tiny little thing that you can talk to that's on a control system, your fridge. It doesn't need the internet. It uses a tiny amount of information. And now it's in your fridge. It doesn't need to know what's in the fridge necessarily, but it can say, I can optimize the flow of energy within the fridge to reduce your energy expenditure, right? Things like that. And that at we're talking like an $8 chip kind of thing.
Or picture the tricorder from Star Trek.
Yeah, right. That's well. Think of the Wi-Fi decompose, right? It can see through walls. It can sense sensor information without even being, it can just do it from the wobble of the Wi-Fi RF signal. Now, if you have actual brain connections, like one of those Muse headsets, it can decipher the brain signal. It'd be interesting to see actually. What does MinCut do on that? I don't think anyone's tried that either. But yeah, lots of crazy. Oh, I got a white one of these now too. Thanks.
Nice. We got a question from Gautam, and then Mondeep. We'd love to hear about Assam and the meetup, and then get to Chris too. Did we lose Gautam?
Nirav,
There he is.
am I audible? Yeah, great. So when you said that you don't need internet to access your AI, so how do you, I mean, how do you define that? Is it because I joined a little late, maybe I missed the first part. So how does your AI work? Like, is it do you have a complete LLM offline or
let's come back to this. I think I want to give Mandeep a chance to tell us about what he did in India. But I'll come back to it, guys. It's self-contained. It's all in one package. Is the moral of the story.
so there's no
Thanks,
AI you can.
thanks, Gautam. We'll come back after the one. So Mondeep,
Yeah,
congratulations on the first chapter event in Assam.
Yeah, it's actually the
Wonderful
second one.
photos.
It's
That
actually
was the second one.
Yeah. So Benz
That was
and I
fast.
had an initial kickoff from London. So he's been we've been working in tandem some of this stuff,
Right.
and this was the in-person meetup. So we were sponsored by a friend of mine who has been established there for 10 years. He's running a company for around 200 people. But so we had a venue effectively, and we started off like probably around 40 days ago, this whole initiative. So I'll quickly share my screen just to kind of give you a view of what this is about. Is that so 11th of February we met. There were over, I think, in the room probably around, with a rooftop basically, and we had around probably 50, 60 people there, and a lot of people joined online as well. And effectively mainly from the northeastern part of India. And just for those of you who are visual, I want to just take 30 seconds to tell you where this place is in the first instance. So if I go to the maps here and I zoom out, so this is India, right? And in India, in the northeastern part, in this part, which is China, Bhutan, Bangladesh, and Burma here, there is this sub-Himalayan foothills and this valley here. So that's Assam. So we had the event around here in Guwahati, right? That place. So a bit of that geography. And to my motivation for this is that this arguably is the most diverse spot on this planet from an ethnology, basically demography point of view, because you got humans moving from all over the place in this area. So unique challenges, unique problems, unique opportunities. And there is also a lot of investment from basically India into this area because of its significance geopolitically. So, and also generally, there's a lot of infrastructure. So idea was really, we put together a constitution to say, how do we make sure that we ensure that we carry along the region its unique diversity, its problems, its solutions into this agentics era. And there has been a big uplift of tech companies there. Not so much like Bangalore, it's catching up, but there's a community developing. So we had this session, and I'm conscious of my time here. So we had an introduction. We basically, it was a very introductory session on what is Agentics Foundation, what is Agentic AI, what do we do here, and then basically what is the mission, linguistic sovereignty, economic upliftment, education, and social governance. And interestingly, I had done an article, and it caught the attention of the chief secretary of the state, and some government officials came in as well, who were very interested to hear what we are doing. And I'm hoping that together as a community, we can basically plug the local needs with the global community here. So we can create a bridge of opportunities and problem solutions. So that in a sense is what we did. Benz, if you are here, you were there as well, so feel free to chip in.
Yeah, it was amazing. The lines were completely perfect, so I didn't feel that any kind of distance geographically from the place. Logging in from London, and I had the chance to present some London and European projects. So that was a great experience.
Yeah, and we also got featured in some of the news, which was nice. But that's all. So we're looking forward to building. So we are having some monthly sessions going forward, some community build sessions. One is there tomorrow. So that's it.
Nice.
Thank you.
It sounds like a great location and a great event. I'm excited to see the Indian community really come together in Gentex. And when I was there a couple weeks ago, I wish we would have aligned. I only booked the flight like a week before I left, but I could have stopped by. There was a nice crew that showed up, by the way, in Bangalore. Like they flew in from all around the country. Craftsman really did a great job of sort of organizing impromptu get-togethers for breakfast before I had to go off and do my business. And yeah, we did. I had was it the dosa breakfast? It was, and it was a lot of fun. I met a lot of really interesting people and had some really cool discussions. Nick in particular, Nick Nickel, he's a kind of a what do you want to call him? A kind of yogi AI transhumanist is what I would call him. And he's got this really interesting sort of this approach where he's blended yoga with AI and this kind of this form of enlightenment. So he wants to do he tells me his family comes from a long line of basically yoga masters. I don't know what the right term is, yogis. And anyway, so he wants to do an agentics meetup, and he's got a facility, a house. I don't know what he was telling me about that, where he wants to make this a thing. So we got to do more in India, is what I'm saying.
He's hosting. He's made that space available for Craftsmen in Bengaluru. Yeah, for that chapter. So really.
Oh, he's got
By the way, they got inspired by our post from the Assam chapter because he picked up that thing. Then can we start a chapter in Bangalore? I said yes, absolutely, go ahead.
Yeah.
So
and I've got a client in Chennai. They've got their technical team in Chennai, and this is a very large I don't know consumer tech company. But I'm pretty sure we can convince them to maybe do some sponsoring of our events. I've had a preliminary conversation with them, and they seem open to the discussion. And they're big, like many billions of dollars kind of thing.
Yeah. We always have to read between the lines on those ones, but it narrows the field.
I do. I have a tendency to
overshare
overshare on these calls, but that's the benefit, I guess.
Cool. All righty. Chris.
All
how
right,
have you been, Mr. Royce?
I've been great. So I'd like to share I guess a few things that I've been working on. So recently I had the pleasure of a client needing me to do something for them, and I ended up building an AI system that uncovered the information they needed to be able to win a $90 million lawsuit case. And so I'll share with you the system that I built, and I also open sourced it as well here on GitHub. So this is an OCR system with full provenance. Okay. So what this does is this connects into the Data Labs API, and it supports these 18 file types, and it converts all of these file types basically to text, right? It does full OCR on these documents, and it identifies images as well, and extracts full tables, everything all at once, right? So let's say we have a document like this, which is a pretty complex document, a Word docx file with some images, tables, things like this. What my system does is not only does it do the OCR, it identifies these images, such as like this picture of this foot here, extracts these images, passes them through Gemini 3 Flash, and then Gemini gives a description of the image that gets stored and that gets embedded, right? And so all of the OCR from the documents get chunked, get embedded, the images get embedded, and there's provenance throughout the entire system. You can always track everything that's happening at all times. Okay, so we have it's all getting tracked through like SQLite databases, right? Number of all of this information, right? And so at any point in time, the entire system can always track all of its findings back to its original location, right? So I was given 1,200 documents, PDFs, Excel sheets, Word docs. These are like 600-page plus long, witness testimonials, expense reports and Excel docs of vacations and, all kinds of stuff. So I OCR'd it all. I created this MCP tool system that exposes the tools to the AI model that allows it to be able to, you know, OCR, do the extraction, manage the databases, search through the databases. I expose like semantic search, BM25 search, a number of different search capabilities to then give the AI the ability to search through the information and identify and extract the information that you're looking for, right? So like in this case here, they wanted, say, like an expert witness analysis, right? And so it was able to break down, you know, like say the witnesses, these are the findings, the good things that you have going for you. This is why, these are the things they said. This is the page it was on. This is the line it was on this page in this document. So it can be like, this witness said this thing on page 382 of this 700-page long expert witness testimony, right? And it like all of the insights it gives you provenance, full provenance back to wherever you want it to go, right? And so you literally just tell the AI, go OCR this folder or this directory or this file, and it'll do, say, all 1,200 files all at once. I just went to bed and woke up. It took like 3 or 4 hours to OCR like 1,200 documents, and with the Gemini API calls on the image extraction. And then it was just about, once you have the information, it's all in, say, this SQLite databases and stuff, all vectorized, and you can search through it all. And then, yeah, then you can just start asking your questions, and the AI can then navigate through large corpuses of data that it normally would not be able to.
How did it help them win the case?
Just some information on some of the things the witnesses were saying, was things that they did not realize, that they didn't catch, right? And that they were able to utilize to win the case. So it was,
how much of that 90 million did you get?
Yeah.
Yeah, a little bit. All right. So you know, that was fun, right? And so this was open source. And then another thing that I opened up on here is another thing that I was playing with while here. This I was working on building an AI memory system. And so I was building a context graph where I was trying to build a system in which the AI could have better context and understanding, right? So what I built is a system that uses 13 different embedders. Okay, so we're embedding memories in a number of different embedders. So one, your standard semantic embedder, and then I created 3 different temporal embedders, one that measures the structure of time, and then another one that embeds your position within time, and then your sequence within the sequence of events, like a sequential embedder. And then I was playing around with this causal embedder, and causal embedders don't really exist. But what I was wanting to do, or working on doing, is I hooked an LLM up and having it analyze whatever documents or whatever information it was analyzing, looking for like cause and effect relationships, or I took a data set I downloaded from Hugging Face of cause and effect relationships, and I was working on LoRa-ing an embedding model, right? And so what the LoRa of the embedding model was doing was essentially this, all right? So let's say this is a representation of a embedding or vector space, right? Like a 3D UMAP representation, right? So let's say this is a node here. We got 2 nodes, all right? Let's say one is cause, is like the cause embedded, and then the other one is the, say, effect embedded, right? And then what the LoRa was doing was then pulling these 2 together, closer together, so that the effects and the causes showed up closer together in the embedding space. So when you searched for an effect, the causes showed up next to it, or when you searched for a cause, the effects would show up next to it, right? And so that was one sort of type of intelligence that I was trying to get working, but I think it's pretty domain. Like you could train it like domain, and then it would work well if you kind of knew what kind of information and you kind of had like a domain specific type of deal. Then it would actually work like extremely well. Then there's a code embedder, right? So it was embedding with the Codo embedded 1.5 model, and then this stuff is like getting mapped out. These memories are getting graphed, and you can see when it searches here. Let's see, I was like using the system, and it stores like a memory, goes through all 13 embedders. It does take on my GPU like 400 milliseconds, 500 milliseconds to store, like, say, a memory. But the real value here is the scalability, right? When you're looking at, say, a vector or an embedding from when you have a single embedder, after like about 4 million documents, things start to get a little blurry. Your results start to really degrade a lot. But when you have 13 embedders, right, or however many you want to have, you can have as many as you want. And you're just basically analyzing the situation or the data from different perspectives or different angles. All right. And so according to just like Claude, just doing some research on my system and what exists and predicting with, say a system like mine with the embedders it has, that it could probably be effective at searching and analyzing data up to, say, 50 to 250 million documents, compared to a single embedder being limited to like around, say, 4 million documents, for example, right? So there is some use cases where this is like very valuable, but
yeah. It sounds
yeah.
like you're looking in the same areas I am. It's really exciting to see your work here. The other thing that you might want to consider is you can use micro LoRa on an embedding model, and that's much more efficient than trying
Micro
to
LoRa instead of regular LoRa.
yeah, micro LoRa. So you're doing micro sort of alterations as you interact with the embedding model. So as requests are made, you're basically optimizing the embedding model, and that's happening. No GPU required for that. And it's gonna, so the more users you have, the smarter your embedding model or even your language model might get as you do it.
Cool.
Yeah, but it's what you're doing is spectacular. I love it. You're just as crazy as I am.
Yeah.
It's perfect. Oh, I lost my video here. Yeah, so nice work. And where can folks see this or try this?
I'll post the repo links in the chat right now. I'll do that for you.
I love that we're all exploring sort of similar concepts in completely different ways, right? It's inspiring. It's really inspiring to see the work you're doing.
I was looking into dark factories too, Ruben, right? So like a software dark factory, supposedly there's 3 of them on the planet that does like software development, like pretty much end to end or whatever, right? Where the developer just writes the specs and then like basically tests and verifies the outputs, right? And like some of this like strong DM or something is like some dark factory is like, I guess like the leading one or something. But apparently what they did is they're using some of the things they're using is dual twin like universes for like sys services, like Google services, and all the services. They have basically Docker containers that the APIs return like what you would normally get from those actual services, right? So they have like a number of that. Yeah, there you go. Gurgly linked it in the chat. And then there's instead of like tests, you have scenarios, which is basically like user stories, like behavioral testing environments, but you keep them separate from the code itself. So the AI working on the code has to pass the test, but can never see the test, right? So it can never game the test. So that was
that's the blind test I was talking about earlier. I think is a similar idea, right? You need some way to sort of validate that it can do what it says it can do with data that already exists. Now that works for things that have already been discovered, but if you're working in the space of never been done, never been discovered, there's a bit of faith that you need more than a blind test. But there's a lot of areas where blind tests work quite well. Yes, this is an interesting article that was shared. So this is the yeah, it's cool. So test-driven development, validating scenarios in the digital twin universe. Interesting times we live in. I'm gonna have to dig a little deeper into that one later. Thanks for sharing that. Noah, you get a comment?
Yeah, Chris, thank you. Can you guys hear me?
Yes.
Okay. I'm curious about your the system for the OCR that you built, where you're having all these different embeddings, the embedding models. Like, how are you consolidating the variance between the models when it comes back to the user, I'm wondering, is there a layer where everything meets in the middle to as far as like
I don't have those 13 embeddings hooked up right now to that OCR system, but
okay.
the OCR system does have it built into where, there's 13 embedders and you can do searches, like embedding searches across the different embedders, but you have to just make sure you're always comparing apples to apples. But the AI can adjust the weights, right? So it can make it so that the temporal embedder, like the things that are more recent, are higher weighted in its search pullback results, things like this, right? So it can apply, variable weights to all the embedders in its search, which is really cool too, right?
Right.
And
Yeah, that's sorry, go ahead.
And for those who aren't familiar with the idea of an embedding model, you can think of an embedding like let's for a moment say that the vector latent space is actually the universe, it's outer, it's galaxies and whatnot. What the embedding model acts as is kind of like a star map. It allows you to take the input, which could be words or math or whatever information that you wanted to sort of translate, and then says, here's the sort of optimal sort of structure location, the vector information and where it needs to reside and how to traverse that. So it acts as a kind of, again, universal translator / star map for the location of the information. Chris, would you agree with or disagree with that analogy?
No, I agree. Like, even for a moment, I almost thought that you can almost calculate anything in the universe mathematically with the embedding space, depending on what you embedded, right? And because there's
Exactly.
meaning behind those numbers, right? Because that's what you're looking. Those numbers have meaning depending on what you're training it on, and whatever depends on the meaning. But that is a way to mathematically calculate meaning in whatever, just figuring out that angle, right? So
exactly. And
Chris, oh, sorry.
Oh, go ahead.
That's really interesting to say that, because that's what I've been on my mind a lot lately, is trying to kind of see if there's a way to actually extract the underlying patterns. And I'm been really interested in using group theory for this, by trying to kind of traverse across the hyperdimensional space and see if you can find structural patterns across disparate domains, using group theory, and then comparing them using all the different types of analyses used in fractal geometry and group theory, to see if you can actually extract essentially similar shapes across the dimensions that seem to be in different domains, but then pull them back into a semantic layer and see if we can analyze to actually kind of automate insight. You know what I mean? Because
that's what you're describing is almost exactly what I'm doing when I'm describing my sort of root vector sort of analysis. And one of the biggest and most interesting things that I discovered doing almost exactly what you just outlined was last week when I mapped the 5 different human genomes in a sort of hyperbolic vector space. And what was interesting when I did that, I discovered that the DNA structure itself actually looked more like a map and a key than it did a storage device. And once I mapped it in that vector, the hyperbolic vector space in particular, it opened up a secondary grouping of information that wasn't evident in the initial sort of flat 2D view of the DNA sequence themselves. The sort of, the letters and whatnot that you get in a traditional output is basically like looking at like a 2-dimensional map. It's like a map that's printed on a piece of paper. But as soon as you take that and you sort of look at it from the signal and the information it lays out in a sort of different 4-dimensional space, all of a sudden it appeared that the DNA itself essentially, and this is going to make me sound like a maniac, but essentially the data exists in a secondary latent space that wasn't obvious. So if that is true, that means that DNA, the information contained within DNA most likely exists in a secondary quantum latent space. And the DNA itself is just a pattern that helps you traverse our physical space to that secondary space, which is absolutely mind-boggling. So if that is true, I'm not saying it is, because I'm essentially claiming that we're piercing the fabric of reality and that some bits of information exist beyond our own reality and can be mapped in a hyperbolic vector space, which is now the sort of things that you described, and I think what some of the things what Chris has just described. So we're all coming to these weird,
No, yeah,
strange conclusions.
that's exactly that's the thing, right? Because I was thinking the first idea that I had, why I even had this idea was to see if you could extract some kind of common meaning beyond semantics across languages by embedding different languages and then doing group theory like on each one, and then using the shapes that emerge from that as consistent structures, and then do a new layer above it to see if you can extract meaning that goes beyond semantics, because the hyperbolic space will look different for each language because we have different cultures, different associations and everything. It's not going to be exactly the same. The shapes won't be the same, but maybe we'll find repeating structures across the language that drive towards deeper meaning, that don't have anything to do with semantics. That was kind of like where the first idea came from.
Yes, and what you're describing appears to be true. So if that is the case, and I'm going to go into sci-fi territory for a moment, but if that is the case, what that potentially means is there's a space outside of our own space that we can potentially map, traverse, and understand. Now, taking that a step further, if our DNA essentially is a kind of map and key to that secondary space, that really opens up a whole variety of different interesting concepts when it comes to like traveling through space, for instance. So let's say you wanted to go into outer space. I know it's going to sound like a maniac, and I'm trying to sound like a maniac, but let's say you did. Now this meat robot that we're in right now isn't going to survive a trip across the galaxy, and it wasn't meant to do that. But hypothetically, you could, if you've got enough computing power, you could map the construct of all your sort of identity, consciousness, whatever you want to call it, put that into a kind of quantum like state, and then allow that to traverse that latent space outside of our space and then re-enter the space at a different point. Meaning, the laws of physics outside of our reality are completely different than the laws of physics inside of it. Kind of like how we define a graph structure inside a hyperbolic vector, right? The graph acts as the kind of reality in that space. Now, if you go outside of it and you can traverse it, like much like we do when Chris is describing his embedding model, you can then manipulate and go around versus through, which allows you to travel in multiple dimensions in a kind of instantaneous fashion, hypothetically. Which also states that the very act of our consciousness might actually exist outside of our actual physical being itself. Again, Friday afternoon crazy, and I apologize if I'm going too down this weird rabbit hole here, but the moral of the story is the more we learn about this idea of vector, attention, various forms of AI, it becomes clear that there's this weird kind of quantum entanglement between intelligence, understanding, possibly consciousness that sits beyond our physical self.
Right.
All right.
It's in keeping with writings and philosophies all the way back millenniums. Bhagavad Gita.
Yeah, I think therefore I am, that kind of thing. Yeah.
Mm-hmm.
Vlad, you've had your hand
Excellent.
up. How's it going? Yeah.
Can you hear me?
The agentic yoga. Yeah. Hey, how you doing?
Very good, very good. Yeah, I just was listening what you talking just now, and I've been working on comparing different things, like for like I don't know, like 6 months, right? And I found like maybe 2 months ago there is the whole thing. It's not the category theory; it's called the type theory.
Mm-hmm.
And in the type theory, that's when people say you should not compare apples to oranges. You can actually, the whole compare thing, it implies the type. And so if you type basically, and the types, they all go into operation. So for example, if you try to load the airplane, you do compare apples to oranges because you want to see and they essentially same things because they come in boxes and they weigh about the same, right? And for example, like the barbells are not, right? And And so when you always work, so like if you look at the type, so the comparing without type, it's actually meaningless operation. So you always compare the types of like object under the type, like so you can actually typecast apples and oranges to the type of like shipping like items, right? Or it could be like, so if you make an apple cider, like then you do have a type of like what kind of apple you use, and the oranges do not fit in that space. But basically, if you're kind of working that space, especially for comparing in provenance, I found the type is very helpful. And that's when you start building embeddings and stuff like, so you, if you build embeddings under the type, like some things sometimes would be the same, sometimes they would be different, and depending what is the type of like you working under. Does that make sense?
Yeah. I think I follow your train of thought. You're having like a kind of molecular structure and density and of the package.
No,
Is that
it's the type. No, it's a view in the world, right? So if you're, it's a whole thing. It's called type theory, right? So, if, for example, if you go like back to computers, right? So, for example, if you work in integers, right, then 3 and 3.5 is the same, or 3.2 is the same thing, right? But if you like go into the, and 3.5 is more than the like. Actually, it's the same thing, right? If you go to Floyd's, 3.5 is actually greater than 3. So if you step more and you go to complex numbers, that's an extension of the type, right? Then there is greater or less, it doesn't apply to complex numbers like anymore. So that's if you just look, if you just read about the type theory and see if you can apply, it's actually kind of friend with the category theory and the group theory, but it somehow it gets less publicity these days, but it's an interesting branch of mathematics, I guess. So that's
okay? Yeah, I lots of interesting things to explore. Speaking of, I think hopefully Brad's still with us here. He's been working on his symbolic reasoning. And Brad, are you still on here? I can't. I don't know if I see his name. Maybe we lost him.
He had to hop off at 1 o'clock.
Oh, I lost track of time again. One of those days where we get blabbing and all kinds of here.
Nolan's still on the call, because I know Nolan's been running some stuff and experimenting, poking around with the AISP. I don't know. Bot, Nolan.
There was a buzz, and I think we talked about last week or a couple of weeks ago. There's that new theory improver, and people like attach agents to it. Did you play with that?
I already built my own lean 4 theorem improver last year.
The lean 4, yeah. So
I have a tendency, and you guys probably know this by now, to like just build my own thing and use it, right? I probably should spend more time looking at others stuff, but my lean 4 theorem improver works great, and I use it for all kinds of stuff. So it's I didn't bother looking at it outward. I should probably. Yeah, I think it's trying to do the same thing.
Okay, that's good.
Yeah.
Did you? So what does it do? Did you try to throw back undecidable problems at it and see what?
Yes, that's exactly. And I used it. I turned out the most useful use case for it was in my AI defense system. And what it did in the AI defense system is essentially hacked itself. It said, how can this language model or other models be exploited? And then I just did that really in a sublinear form, so super fast. And then at which point I'm able to sort of essentially find exploits before the request is even essentially the instant the request is made, so it doesn't add any latency to the request. And it's essentially saying, is this request potentially a vulnerable request to the system? And then it tries every possibility of that particular request to determine if it's going to exploit the system. That the lean 4 theorem in the most basic terms is creating a novel form of mathematics, many forms of mathematics to try to exploit the system. Now, inversely, it could be used to exploit others, I suppose, but I didn't bother looking at that vantage point. But it does work really well for preventing the exploit of the system itself. So now you're not dependent on heuristics, right? There's no pattern matching. It's low latency discovery. That could also work for all kinds of other things too. But back to medical, anything that involves a variety of signals that you need to decipher. Yeah, it's interesting stuff. Stu.
Yeah, just a quick question on the Cognitum. I know you mentioned there was a pre-sale. I tried to do it. It didn't seem like the Stripe is up yet. I couldn't remember if you said that
No,
was
it's not.
live and we could
No, it's not.
actually.
It's not
Not
live.
yet. Okay.
I haven't even incorporated the business yet. So I still have to get. We managed to win a CES award before
That's
the
what I
company
saw.
was.
That's great.
Yeah, before the company was incorporated. We don't even have a bank account yet. So tons and tons of interest in the pre-sale, thousands of people at this point. So I gotta get my act together. We should have that. I think I'm gonna aim for like the first week of March, I would say. So a couple weeks from now, I guess. And you'll be the first to know. Yeah.
Okay.
Again, I want to.
Friday.
Yeah, I want to make sure that again, I want to make sure that I actually got you guys something that you can plug in, right?
Yeah.
I don't want to just do a pre-sale and take money and then say, oh, you're gonna get it in 8 weeks. That doesn't seem right to me. So I want to have like, okay, you can get it and you're gonna get the cognitive seed. The seed is essentially the most powerful sensor component within it. So you can do all kinds of the stuff that you've been seeing on this presentation today in a sort of very low latency environment. So super fast. And then a few weeks later, I'll get you the appliance, and then you can run everything. Soup to nuts.
The other question is, have you taken all of this knowledge, all of these meetings, and put them into your own RuVector knowledge base so it knows all about what you're teaching and talking about and conveying and doing?
That's a good idea. So when you look at the RuVector, you notice that I've got several different structures for the sort of the vector space, including language, video, audio. That's how we did that's how we did the bird system that communicates and deciphers bird conversations. So we can completely do all that. I've even got what the heck do we call that? It was a visualizer that used I guess what the hell do they call that thing? My brain, I'm tired. I didn't get sleep last night. Moving on. You're not getting me on my peak mental capacity
No,
today.
that's all right. I mean, that's what I've been trying to do with the Ask RoofNet, and I've been loading in the last couple of months worth of these meetings, plus all the latest components and everything. Like every day, I'm having it sweep your stuff and take a look at the latest repos and pulling them in and embedding them.
Oh, you should definitely try I'm going to publish my new updated Agent DB later this afternoon. But the chat system, again, self-contained. It includes the ability to pop in MCP servers. So this is again self-contained. So you could have all the data and in here. I'm using this interface is actually using the Hugging Face chat system that is contained within the RVF format. But for the stuff you're doing, the RVF might be really useful for you because it's one file to rule them all kind of thing, right?
Yeah.
So you can get in here and change the model and then I think there was a question earlier about this as well. Add your own little models, or you can add external models, I suppose, if you want to. I've only focused on internal, but the external would just be an API. But that would be, you could package up the entire Rube chat as a single RVF.
Excellent. Thank you.
And let me know. I can do a PR or something. Like I can help you. I'd be interested in using that.
Great. I'm finishing it as we speak, and I'll look to publish it out.
Yeah, that'll be awesome. I've got a new. And for those who love absolutely crazy things, I'm pushing out a new sublinear system for RuVector later this afternoon. And I'm not going to go into all the details of its crazy, but the moral of the story is I made it even faster by like thousands of times. So it'll run. And remember, when you look at speed, the speed reduces energy and reduces the requirements of needing to use a GPU and allows it to learn and understand even more quickly. So
Okay.
you'll see a project here. I'm gonna share you guys with this just quickly. This is probably right up Chris's alley, to be honest. Let's share my screen here quick. I should have been sleeping on the plane last night, but I ended up building this. Where is it? So under, oops, this is my quantum. All right. This is my root vector. You'll see there's a solver folder here. Hopefully you can see my screen okay. In a few months back, you would have remembered my sublinear time solver system. This is essentially this is basically a sublinear time solver system applied to the vector space that I've been doing. I need to create a better README that explains it in simple English. Almost ready to publish, but it'll be a fun little tool to play around with, and it's ultra fast.
Got it. And the only other question was there were a couple of I don't know if they're issues or update requests that now that Opus 4.6 is out, it's doing some of the things that Claude Flow is doing. There was a Mac had sent you one, I'd sent you one on some things that you could do to Claude Flow V3 to have it fully level up, leverage.
I did that 45 minutes after they launched the service. It's been out for a couple weeks.
Got it.
Yep. Yeah. So specifically, you're talking about the memory and the teams. There's 100% fidelity with my system, so it took 45 minutes. And so now for the teams, when you do the init in Claude Flow, you'll notice that in the settings.json, it enables both the memory and the teams capabilities within Claude Code. So when you spawn up a swarm and do all this you're getting all the memory and all the other components completely integrated. So what I'm essentially doing is I'm doing a drop-in replacement for they're basically just using like a JSON, or I think it was JSON based memory, and I'm rerouting that JSON memory to my my root vector memory store that's in Claude Flow. So it gives it the learning and the optimization. They still do no learning. It doesn't self-optimize. It's basically just a prompt that says remember this, which isn't ideal. So you're going to get all that, but you may have to re-init to do it. And there's a migration option in Claude Flow. So if you've already got an existing repo, just run the migration, and it'll take all your existing memories and whatever and migrate it to the correct format.
Ruv, if I'm using the root vector Postgre Docker, remember when you created that?
Yeah.
If I like redeploy that, will it pick up the latest or not?
Oh no, I haven't. I have to repackage it. I don't do as many updates to the Postgre because it's I'm using it in production, and so it's
right.
I'm only pushing the most solid, the most capable elements and skipping everything else.
Yeah, you can't mess around with that.
Yeah, I'm not giving you all the crazy.
The other question is, have the aliens gotten back to you yet?
Yeah, I didn't create a communication channel, but I'm unfortunately I'm out of time today. I've got a packed afternoon of calls. So how's the hockey game going, Nick?
We came back 3-2. So the Canadians are off to the gold medal game, 8:10 Sunday morning. I can't say I have too many adult beverages before noon but there might be a few going down on Sunday morning.
All right. Sorry, and we beat Finland. Is that who we were playing?
Yeah. But they showed up. They got out to an early start, so they definitely played a good game.
Oh, sorry, Timu. All right. Until next time. Next week, we're gonna do the Vibecast. I'm sure there'll be something we'll dig into. Thanks everyone for showing up. Again, my brain isn't quite fully at 100% today. I should have slept last night, but you got me. Rob, what am I missing? Anything?
No, great stuff. Welcome home. Amazing week, and we all got tons of repos to dive into. Thanks, everybody. Chris, Mondweep, Benza, everyone.
Thank you.
All right.
Thank
See
you.
you
Have a good
guys soon.
weekend. All right.
Good weekend.
Thanks all. Bye-bye.